Hello everybody, it's time to learn everything we can possibly learn from VisionOS documentation. Here in our 23rd video, let's create a performance plan for your VisionOS app and identify your app's performance and power goals and create a plan to measure and assess them. Performance tuning is an important part of the development process regardless of platform. Performance tuning means making your app run as efficiently as possible, so it does more work in less time and with fewer system resources. Efficiency is especially important on devices that can support multiple apps in an immersive experience. Apps that consume too many resources can push the device beyond the thermal limits. When this occurs, the system takes steps to cool down to a more acceptable level. This can have a noticeable visual impact and can be disorienting for the viewer. As you start development, set aggressive goals and evaluate progress throughout the development cycle. Automate the collection of performance metrics as much as possible and look at data over time to see if performance is improving or declining. When you detect a significant decrease in performance, take immediate steps to correct it. When you start fine-tuning early in the development, you have more time to take and make needed changes to algorithms and approaches. For more information on performance tuning, see Improving Your App's Performance. Set performance and power targets. Performance isn't a single metric you measure and improve. Typically, you choose several metrics and set goals for them. For example, consider app launch and load times. Make sure your app launches quickly. This is your first chance to make a good impression. Responsiveness and latency. Your interface needs to respond quickly to interactions, even while doing other work. Minimize the time it takes to start tasks. For example, make sure audio and video start without noticeable delays. Graphics rendering. For an immersive experience with real-time rendering, it's important to maintain consistently high frame rates. Help maintain these rates by avoiding unnecessarily changes that result in more frequent updates to the shared render server. Measure things like updates, rates, stalls, and hangs in both the render server and your app. Only render the content you need and optimize the textures and other resources you use during drawing. Power usage. When the device begins to reach thermal limits, the systems reduce CPU or GPU usage and performance degrades over time. Avoid this thermal ceiling by prioritizing and spreading out work, limiting the number of simultaneous threads your app maintains, and turn off hardware-related features like correlations when you don't need them. Task efficiency. Make the app do as much as possible using the smallest amounts of hardware resources. Minimize task-based overhead. Memory footprint and bandwidth. Use as little free memory as possible. Don't allocate or deallocate memory during critical operation, which might make your app appear slow. After you choose the metrics you want, set realistic goals and prioritize them, so you know which ones matter the most. Performance tuning often involves making trade-offs between competing goals. For example, if you reduce CPU usage by caching computed data or preload assets to improve responsiveness, you increase your memory app usage. Make these kind of trade-offs carefully and always measure the results of any changes to learn whether they were successful. In some cases, you might find the sacrifice isn't worthwhile. Consider how people will use your app. If your app runs in the shared space, consider more conservative targets and goals for system resources. If you expect people to use your app for long periods of time, factor this extended use into your target and goals when choosing metrics. Identify the code flow and user scenarios to test. After you choose the metrics to collect, decide which portion of your app to test. Choose features that are repeatable, measurable, and reliable to test. Repeatable automated tests allows you to compare the results and know the comparisons represent the exact same task. Focus on places where your app executes code, but don't ignore places where your app hands off data to the system and waits. If your app spends a significant amount of time waiting for information, consider eliminating the requests altogether or batching them to achieve better performance. Focus your tuning efforts on the part of your app that people uses the most, or that have the most impact on overall system performance, including user-facing workflows, key algorithms, tasks that allocates or deallocates memory, background and network-based tasks, custom metal shaders. Choose actions that people perform frequently or corresponding to important features. For example, if your app lets someone add a new contact, test the workflow for creating the contact, editing the contact, and saving the results. Test your app with a particular feature enabled or disabled to determine whether the feature is solely responsible for any performance impact. Choose lightweight workflows, such as how your app performs at idle time, and also heavyweight workflows, for example, one that involves user interaction and your app's responses. For launch times, gather metrics for both hot and cold launches. That is, when the app is already resident in memory or when it is not. Consider thermal and environmental factors. Consider how environmental factors impact your app. The characteristics of your physical environment can affect system load and thermals of the device. Consider the effect that ambient room temperature, the presence of other people, and the number and type of real-world objects can have on your app's algorithm. Try to test in a different setting to get an idea whether you need to optimize for these scenarios or not. Use Xcode thermal inducers to mimic the device hitting its thermal limits, and consider how your app responds to fair, serious, and critical thermal notifications. You might need to have different performance goals under thermal pressure and prioritize optimizing for power or finding ways to dynamically lower your app's complexity in response to thermal pressures to give a smoother experience, even if latency is a bit high. Choose tools to collect performance data. There are many tools and APIs you can use to collect performance-related data for your VisionOS app. Use a variety of tools to make sure you have the data you need. Debug gauges. Monitor the CPU, memory, disk, and network gauges in the debug navigator to track system resource utilization. Instruments. Profile your app to gather performance data on most metrics. Instruments let you profile your app's code execution, find memory leaks, track memory allocations, analyze file systems or graphics performance, SwiftUI performance, and much more. Use RealityKit trace templates to monitor and investigate render server stalls and bottlenecks on VisionOS. Use XCTest API to collect performance data. Use MetricKit to gather on-device app diagnosis and generate reports. Organizer reports review diagnosed logs for hangs, disk, and energy usage, and crashes in the Xcode organizer. Review statistics on the content of your RealityKit scenes using this information to optimize your 3D models and textures using Reality Composer Pro. Signposts. Add signposts to your code to generate timing information you can view in instruments. For more information, see recording performance data. Log messages. Include log messages to report significant events and relevant data for those events. For more information, see generate log message for your code. Test flight. Get feedback from testers about their experience with the beta version of your app. Fill out the test information page for your beta app version and request the testers provide feedback about the performance of your app. Profile on physical device. In general, profile and analyze performance on the physical device rather than the simulator. Even if something works well in simulator, it might not perform as well on device for all use cases. Simulator does not support some software features and APIs. There are differences in the rendering pipeline for simulator running on the Mac OS, so rendering performance characteristics will be different. Other pipelines, such as input delivery, audio, and video playback, are also different. There are, however, some insights you can gain profiling in simulators, such as CPU stalls, that will help you spot areas to investigate and address. Build automated test cases and run them regularly. Xcode comes with tools that help you automate the collection of performance data. Use XCTest framework to build test cases to collect performance metrics. XCTest lets you gather several different metrics, including the time it takes to perform operations, the amount of CPU activity that occurs during the test, and details about memory or storage usage, and more. Use instruments to collect metrics for specific interactions with your app. Record those interactions and play them back later to collect a new set of metrics. Write custom scripts to gather performance-related data using system command line tools. Integrate these scripts into your project build process to automate their execution. Configure Xcode to run test cases each time you build your app, or create a separate target to run test cases or custom scripts on demand. Integrate your performance tests into your Xcode Cloud workflow or your custom continuous integration solution. Collect performance data using a production version of your app to obtain more accurate results. Debug builds contain additional code to support debugging operations and logging. You can collect data from debug builds too, but keep those metrics separate from production build metrics. For example, about how to write test cases for your app, see Testing Your App in Xcode. For information about automating tests with Xcode Cloud, see Xcode Cloud. Okay, so we have hit the end of this article. We have learned what we should do and what we should measure, but we have not learned how to do it at all. And I believe that it all starts with here, with what we can do, and we'll figure out how to do it when we get there. All right, I'll see you in the next video.